my name is Matthew Gilmer, and I'm presenting research I completed with the help of my colleagues, Stephen Hauser and David Bruner at SizeStream. Now we've made the first step towards correcting for loose clothing rather than just detecting it, and we call this new method of measurement scan over clothes, whose improved accuracy when scanning loose-clothed subjects raises the possibility of providing ready-to-wear sizing and/or made-to-measure clothing with relaxed scan-wear requirements. The top row diagram shows at a high level how our current system works when a user scans with loose clothing. We have our scanning application guide the user into front and side view poses as shown. The images are segmented on device to preserve privacy before being used as input. What comes out of this, in this case, are inaccurate and often overestimated body measurements. The problem is that the segmented images going into the model have been adversely affected by loose clothing. The bottom row shows the solution presented here. Using BPC segmentation, we can supply the SOC model a foreground silhouette separated into two components, blue for body and red for clothes. If the model is trained correctly, it should yield more accurate body measurements than our current solution for scans when the subject is wearing loose clothing. We developed a GUI for labeling and correcting, if needed, the batch process results. So here we have a well-segmented shirt with some noise in the shorts region. We can use the mouse to draw a blob containing the noise and the keyboard to remove it. We can mark it as closed in advance. The next blob shows well-segmented shorts, which we mark as closed in advance, and then we see a noisy attempt at segmenting the whole body. We see a good shirt segmentation, which we mark as closed and then advance. So we can actually guide the engine by drawing a bounding box in the preferred region and run the segmentation. And then, to quantify the quality of BPC subject segmentation, we first evaluated it on a test set, finding a substantial improvement in measurement repeatability and a smaller improvement in accuracy. We find the quality of BPC segmenter's closed segmentation to be at about the same level of its subject segmentation. We looked at a random sample of 100 scans from the wild as a test set, and we found two examples where a garment was partially misclassified at the level of more than just a few pixels, as we discussed the training strategy for the scan over clothes model. We processed tens of thousands of images collected from our various scanning applications and processed them with BPC segmentation. We also ran a batch process of loose clothes detection on all of the scans. We now evaluate the SOC model on dataset 2, giving us our main result. This dataset contains both clean and loose scans. The clothes range from shorts and t-shirt to long pants and sweaters. The SOC performs similarly to BMM 2025 when scans are clean. As expected, we find that BMM 2025 sees massive degradations in both precision and accuracy when used on loose scans. We find that SOC handles loose scans much better than BMM 2025, but remains less accurate than either model on clean scans. Loose clothing does not affect all measures equally. For the case of waist, the average subject had their waist measurement overestimated by nearly 10%. SOC brings this bias basically to zero. We introduced a clothing wear body measurement regressor, SOC, that greatly enhances accuracy when scanning loose clothed subjects. The model may be suitable for ready-to-wear sizing with relaxed scan wear requirements. Even in a lab setting, we saw precision improve by 13% and our accuracy by 2%.